Welcome to Math Simplified. This video is for 9th standard students. Please subscribe and share with your friends also. Start the second chapter, real numbers. In the lower classes, we already studied about natural numbers. It is denoted by capital N. It's a set which contains all numbers. It goes up to infinity. Whole numbers denoted by W. It starts from 0, 1, 2, 3, ... Integers, it's denoted by Z. It contains all negative numbers as well as the positive numbers. This also goes up to infinity. So you have done many sums on this: addition, subtraction, multiplication, problem sums. Okay, so the next type of numbers is rational numbers. Rational numbers also you have done in your lower classes. You have done it as, it as fractions. So fractions, the addition, subtraction, multiplication, division. You know how to convert a fraction into a decimal form. All that you have done in your lower classes. Let's revise once more. Okay, so here what is the general form? This rational number, we'll write it as Q, capital Q, is equal to, contains all fractions like P upon Q, where P and Q are integers, and the most important, the denominator should not be equal to 0. Q should not be equal to 0. Okay, so now this kind of fractions, if you do the division, you can write it as a decimal. When you do it, you realize that sometimes you will get the remainder as 0, sometimes there will be remainder. Okay, so whenever that kind of division you get the remainder 0, that means the decimal has terminated. It is called a terminating decimal. Okay, and sometimes it will not terminate, it will keep on continuing, and that is called a recurring decimal. See, for example, 11 upon 3. You do the division, you will get 3.6666. So it goes on and on like that. So this number 6 is getting repeated. It reoccurs. So you just put a bar or dash over the number 6. That means the 6 is going to keep repeating. This kind of decimal is called a recurring decimal. So this is a rational number. So rational numbers are of two types. The decimals can terminate, or if it is not terminating, it should be a recurring decimal. It will look like this, a recurring decimal. So that is rational numbers. So here, how do we know a particular rational number is terminating or not? You have to look at the denominator. If you factorize the denominator and the factors look like this, it should be factors of 2 and 5. Okay, then it is a terminating decimal. Otherwise, if there are other factors, then it is a non-terminating decimal. Okay, and if it is recurring, the repeating decimals is called the length of the period of decimal. So in this example, 6 is repeating, and this is only one digit. So the length of period is only 1. Supposing, for example, 3.272727, it keeps repeating, means 2 digits are getting repeated. So the period of length the length of the period will be 2. That is how we should calculate. Okay, so let's go to irrational numbers. So what is an irrational number? An irrational number is a number that cannot be expressed as an ordinary ratio of two integers. In other words, or numbers which are not rational, we can call them irrational. So if we do the decimal expression of an irrational number, it will look like this: 4.3257 ... That means what? It is not terminating. At the same time, no digit is repeating itself, like recurring. It's not recurring also. So this kind of decimal expression is an irrational number. So non-terminating and non-recurring decimal expression is a irrational number. Other examples of irrational numbers are square root of all prime numbers, like square root 2, square root 3, square root 5. These are all irrational numbers. Then pi, then Euler's number E, the golden ratio. All these are examples of irrational numbers. Real numbers are a set which contains both rational and irrational numbers. We will denote it by capital R. This is real numbers. Okay, let's go to exercise 2.1. Which arrow best shows the position of 11 upon 3 on the number line? So you're familiar with number lines. This is how it looks. They have plotted these points A, B, C, D. They want to know which point is 11 by 3. So 11 by 3, if you divide, you'll get 3.666 dot dot dot. It's a recurring number, and that means approximately it is 3.7. So the point should be after 3, and it's more than 3.5. So obviously it is this arrow D. D arrow shows the position of 11 upon 3 on a number line. Okay. Number 2, find any 3 rational numbers between minus 7 upon 11 and 2 upon 11. Okay, so these two are rational numbers or fractions. Look, both the denominators are same. So now let's look at the numerator. So what are the numbers in between minus 7 and 2? There are many numbers. In fact, we can say infinite numbers. But let us choose. Say minus 7 to 2 means minus 6, minus 5, minus 4, minus 3, minus 2, 1, minus 1, 1, 0. All these are numbers in between these two numbers. Choose any 3 numbers, put the denominator as 11, and you'll get the answer. So these are the rational numbers in between these two rational numbers. So minus 6 by 11 is in between minus 7 by 11 and 2 upon 11. Question 3. Find any 5 rational numbers in between 1 upon 4 and 1 upon 5. So these kind of sums, where they're asking you to find rational numbers in between 2 rational numbers, we can do in many ways. There are 4 different ways to do it. You can choose whatever is easy and whatever is convenient. Okay, so these are the 2 rational numbers. We can see that the denominator is not the same. So we are going to first find the LCM of the denominator. It is 20. We need 5 rational numbers, so I'm going to take a common multiple which is higher value. So for that, 20 into 6, 120. So this is the multiple I have taken. So I'm going to convert these fractions, the denominator of these fractions, into 120. So write down the fraction. If I multiply by 30, denominator becomes 120. So I have to multiply even the numerator by 30. So I get 30 upon 120. 1 upon 4 becomes 30 upon 120. Similarly, 1 upon 5, I'll multiply it by 24 upon 24. I'll get 24 upon 120. So now both the denominators are same. So look at the numerator. 24 to 30. Choose numbers in between. We need 5 numbers. Choose 5 numbers. 25, 26, 27, 28, 29. Choose them in between these 2 numbers. And write down the denominator as 120. So you get all the required fractions in between 1 upon 4 and 1 upon 5. Next sum. Find any 5 rational numbers between 0.1 and 0.11. So let's write it as a fraction. So 0.1 becomes 1 upon 10. 0.11 becomes 11 upon 100. So we are going to convert both these denominators to 1000. So to convert 10 to 1000, I'm going to multiply by 100 upon 100. This 1 upon 10 becomes 100 upon 1000. Similarly, 11 upon 100 multiplied by 10 upon 10, it becomes 110 upon 1000. So now both the denominators are same. Look at the numerator. Think of numbers in between 100 to 110. Take any 5 numbers and write down the denominator as 1000, and you'll get the answer. Another way to do the same sum without converting to fractions and all this is simply rewrite the decimals. 0.1 is written as 0.100 and 0.11 is written as 0.110. So write down all the numbers in between 0.100 and 0.110. So what are the numbers? 0.101, 102, 103, 104, 109. We should not include 110. Okay, up to 9, any numbers you can choose, and that will be your answer. So as I said before, there are many numbers in between 2 rational numbers. You can choose any. Number 3. In between -1 and -2. So in this, I'm going to show another method to do this. To find rational numbers in between -1 and -2, take the first number, add to the second number, divide by 2, you'll get the first number. So -1 plus -2 upon 2, you'll get -3 by 2. This will be our first number. minus 3 by 2 is in between minus 1 and minus 2. Now to find another number, take again minus 1, add it to minus 3 by 2 like this, divide by 2, you will get the second number. For the third number, again take minus 1 plus minus 5 by 4, evaluate this, divide by 2, you will get minus 9 by 8. For the fourth number, minus 1 plus minus 9 by 8, evaluate it, divide by 2, you will get this answer. For the fifth number, minus 1 plus minus 17 by 16, divide by 2. So this is how you can get 5 numbers. This is also one method to find the rational number in between two numbers. So here we come to the end of the exercise. Please go through the video once again, pause the video in each sum and practice them.